myself, Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So, in this series of computer networks, in our previous lectures, we have covered so many topics which laid down a beautiful foundation for moving further. And today's topic is OSI model. So, when I am saying OSI model, let us first try to understand that what actually this OSI model is, what is the need behind this model, and then we will look into the details of this. So, OSI, as the name suggests, it is open system interconnection. Open system interconnection model, it is actually a model which is developed by International Organization for Standardization, which is ISO. Now, this is actually a model, or you can say it is a set of rules that explains how a computer system is going to communicate over a network, and this is, or you can say this is actually a conceptual framework that defines the process of communication onto a network. And when we look into this model, we find that there are 7 layers, and each and every layer here in this model is having a specific function, a specific kind of service to provide, and also some protocols through which, or on the basis of which the functionality of the layer is going to work. Now, what is the purpose of this kind of model? So, the purpose is to show how communication between different systems can be facilitated without modifying the logic of underlying hardware and software. Now, I am going to repeat this line because here, this is going to lay the foundation for our next concept. So, the purpose here is to show how communication between different systems can be facilitated without modifying the logic of the underlying hardware and software. This essentially means that this OSI system is going to give you concepts in the terms of encapsulation and abstraction, that how actually underlying hardware and software are working. We really need not to modify that logic in order to have the communication system to be established between different networks. And if we want to relate this kind of we can say this kind of concept, so we can say yes, this is related to encapsulation, or we can say this is related to the abstraction as well. Now, layered approach is going to give us an ease for different devices and technologies to work together, because each and every layer in this model is having a different function, having a different service, and having a different protocol. So, it is a clear structure for data transmission and for managing other issues on the network. What other issues on the network I am talking about? So, there can be flow control, or it could be translation from one format to another format, and so on and so forth. There can be so many network issues. So, your OSI model is going to provide a structure, or we can say a foundation for data transmission and managing the network issues. So, this is actually widely used as a reference to understand how the network system functions. Every technology in this specific layer, as I have told you that this model is a combination of 7 layers. So, every technology in a specific layer must provide certain capabilities, perform some specific functions, which are those functions which are useful in networking. Now, how this layered structure is going to help that? Technologies in the higher layer benefit from the abstraction, as they can use lower level technologies without having to worry about underlying implementation details. And here comes the concept of abstraction, which I was just trying to explain. So, higher levels or whatever the technologies are there in the higher level, they are going to benefit from the abstraction, as they can use lower level technologies without having to worry about underlying implementation details. So, when we say 7 layers of this OSI model, these 7 layers or this whole OSI model, we can consider that as a universal language for computer networking. Now, as this whole model is divided into 7 layers, we can say this model is based on the concept of divide and conquer, as this is the communication system which is we can say divided in the form of 7 abstract layers, and these layers are stacked upon each other, and there is a specific, we can say place of each and every layer. Now, what are the names of these layers? Let us see that with the help of a figure. The topmost layer is known as the application layer, and it is responsible for something, and here we have written it in the short that what is the actual function, but in the course of this lecture we are going to take up one layer at a time, and we will be diving into the details of the functions, and what are the protocols which are working on that, what are the we can say internetworking devices which are going to operate on that particular layer. Now, please connect this sentence to the previous lecture of internetworking or networking devices. That time when I was describing networking devices, at the time of that description I have given you reference of different layers. So, these are the layers which I which were being referred there. So, the first layer, or we can say the topmost layer, not the first layer, we can say the topmost layer is application layer, which is responsible for providing the services to the user, because this is the layer which is in directly touch with the user. Below the application layer, the layer is presentation layer. Now, this presentation layer is actually related to the syntax and semantics of the information which is being passed from one particular machine to another machine onto the network. Coming out into the layer below the presentation layer, which is the session layer. So, session, as the name as the name indicate, it establishes, it maintains the session or the communication sessions between the sender and the receiver. Below that we have transport layer, which is we can say responsible for process to process delivery. Now, which process I am talking about, I will be telling this in a short while. Below transport layer we have network layer, which is basically we can say it is responsible for the delivery of individual packets from source to destination. What actually a packet is, I have already told you, you can bundle some data into this packet along with some header and the related information. Below network layer we have data link layer, which is the responsible for a kind of we can say formation of frames or moving the frames from one hop to another hop. And the last, or if going in the bottom up manner, we can say the first, the lowermost layer is the physical layer. Now, this is the layer which is actually kind of we can say communicating the two machines. So, it is the responsible for making individual bits or for transferring or for moving individual bits from one device to another device, or to the we can say just to the next device which is connected to this. So, this is actually the physical layer is going to look into all the physical nuances of bits and all those kinds of things, or even it is related to cabling and so on and so forth. This is related to we can say topologies and all. So, 7 layers here, starting from bottom we have physical layer, then we have data link layer, then we have network layer, on top of the network layer we have transport layer, then we have session layer, then we have presentation layer, and on top of presentation layer or on the top of this complete stack we have application layer. Application layer is directly in touch with the user we can say, and physical layer is directly in touch with your what we call your the next hop, the next machine. So, this is actually a complete diagram, as you can see this on the screen. This is showing all the 7 layers at their respective positions. Now, let us dive down into one layer at a time and look into the details of the functions and the services provided by these individual layers. Now, before going into the individual layers, let us also consider what actually the importance of these kinds of models. And as I have already told you that each layers or the layers here encapsulate every type of network communication across the both software and hardware components. So, without looking into the details of software and hardware implementation and software and hardware functionalities, if we want to focus on the communication process, your OSI ISO model is a go to here. Also, this model was designed to allow two standalone systems to communicate, and these two standalone system or any two standalone systems will communicate via standardized interfaces or protocols which are based on the current layer of operation. So, with this, let us move on to the first layer, or we can say the bottommost layer. It is named as I have already told you, it is named as physical layer. It is the lowest layer. It is also responsible for the actual physical communication or actual physical connection between the devices, and this physical layer contains the information, or it kind of we can say transfer the information in the form of bits. So, here you can see a figure in order to kind of understand that how this physical layer is going to work. So, we have a sending cable which is on the kind of sender's side. Also, we have a receiving cable which is on the which is connected on the receiver side, and these two cables are connected. These two cables are the cables from the systems or from the computers or machines, and in between if you can see there is a bit stream. Now, that bit stream is actually kind of we can say, or moving those bits from sending from sender to receiver is the actual we can say work, or it is the actual function of your physical layer. This physical layer is responsible for transmitting individual bits from one node to the next node, as I have already shown you with the help of a figure. Now, while receiving the data, this layer will get the signal received and then converted it into the form of 0 and 1. Now, please recall the concept of modem, in which I have already told you that these information is actually coming in the form of maybe analog signals onto the media, but your computer or your system is going to possess or process this information in the form of bits, which is 0 and 1. So, whenever sender side's physical layer receives the signals and convert that into 0 and 1, and then it sends that data to the data link layer, which is the layer just above this physical layer. So, it is something like that, we can say that each and every lower layer is going to provide the service to the layer just above it. Now, what are the common physical layer devices which can operate here? Hubs can operate on this physical layer. Then we have repeaters, because these repeaters are there to kind of we can say strengthen the signal if the signal gets weakened down by traveling a lot on the cable. Or it could be a modem, which is there for modulation and demodulation, which is analog to digital and digital to analog conversion, and this layer also deals with kind of cables if we are having a wired connection there. So, the devices which are commonly operated or commonly used on physical layer are hub, repeater, modem and cables. Now, this is fine that your physical layer is responsible for transmitting bits from one node to the next. But moving further, is it the only function of the physical layer? No. apart from just moving these bits from one to another, there are other functions of these physical layers which are actually connected to the transformation of these bits. So, for example, let us say we have one function of the physical layer is bit synchronization. So, bit synchronization is done with the help of a clock. This clock is going to control both sender and receiver, and thus this clock provides the synchronization at the bit level. So, for example, this should not happen that some bits which are traveling from here, traveling from sender to receiver are not synchronized and received at the receiver's end in a haphazard or in a kind of hayway manner. So, bit synchronization, yes, that is important and it is a function of the physical layer. Similarly, it is not only the synchronization but also the rate control, which is the bit rate control. So, the physical layer also defines the transmission rate. So, transmission rate here is the number of bits per second. So, basically this is related to your sender is sending at a pace which your receiver is able to we can say accept, or which your receiver is able to take up. So, this bit rate control is also a function of the physical layer apart from bit synchronization. Moving further, physical layer also, as I have already told you, that this is the layer which deals in physical transmission and your cables, everything like that. So, physical topology or physical layer, this layer defines that how the different devices, how the different nodes are arranged in a network, or basically we can say what kind of topology is going to be followed for the communication. So, that is also a function of your physical layer. Apart from that, what kind of transmission mode is going to be used for data flow between the connected devices. Now, if I am talking about what kind of transmission mode, then there can be 3 transmission modes, as we have seen in the earlier lectures as well. It could be a simplex transmission mode, it could be a half duplex, or it could be a full duplex mode. So, what kind of transmission mode is actually will be used for the data flow between the two devices is also we can say the function of physical layer. So, apart from just transmitting the bits from one device to another, bit synchronization, then bit control rate, physical topology, looking into physical topology and transmission mode also, these are the functions of your physical layer. So, in a nutshell we can say that your physical layer is going to deal with the deal with all the physical aspects, such as cables, connectors, signaling, or even transmission of data in the form of bits between the two devices. Transmission modes, obviously simplex, half duplex, full duplex is the we can say that is being looked into by this physical layer, and this also defines the topology configuration. So, these are the functions in a nutshell of these are the functions of physical layer. Moving on to the second layer, which is on top of the physical layer, that is data link layer. Second layer we can say data link layer, responsible for establishing and maintaining the communication between two devices on the same network. Now, here what is important is on the same network. Now, when we study physical layer, we say that these the data or the information is being transmitted in the form of bits. When we say data link layer is responsible for moving the frames, moving data in the form of frames from one hop to the next hop. Now, apart from this, apart from movement of frames, this is also responsible for node to node delivery of the message. Main function of data link layer is to make sure that data transfer is error free from one node to another over physical layer. So, error it is in order to make sure that the data transfer is error free, this needs to perform certain function, and this is the, we can say, main it is one of the major functions of data link layer. Now, apart on the top of data link layer, there is a network layer. Network layer deals the data in the form of packets. So, when a packet arrives in a network, it is the responsibility of the data link layer to transmit it to the host using this MAC address. Now, when we say MAC address is the individual address of the machine, and please recall the concept of NIC, which is network interface card, and that network interface card is going to kind of provide fixed we can say static address to the machine, which is better known as MAC address. So, packets in the data link layer is referred to as frame, as I have told you that in the network layer, which is on the above data link layer, we call them as packets, and at the data link layer we call them as frames. Now, what is the difference between frame and the packet? I'll tell you in some time. Then what are the common networking devices which are going to operate on this particular layer? Those are switches and bridges. Now, even this data link layer is subdivided, or we can say is divided into two sub layers. These two sub layers are named as logical link control, which is LLC, and media access control, which is MAC layer. So, the packet which is received from the layer above this data link layer, which is the network layer, is further divided into frames. So, we can say some information is being kind of stripped off when a packet is being transferred into a frame. So, the packet which is received from the network layer is further divided into frames depending upon what kind of frame size or how much frame size your NIC is going to permit. So, this is the we can say decision of the NIC's implementation, and then this data link layer also encapsulates sender and receiver's MAC address in the header, because looking into the MAC addresses and giving the delivery on the next side is the responsibility of data link layer, at least at the we can say at least at the level of MAC addresses. Now, receiver's MAC address is obtained by placing an address resolution protocol request on the cable. This address resolution protocol says who has this IP address which is being encoded into the frame of on the sender side, and then the destination host will reply that yes, this is my MAC address, or the destination host will reply with its own MAC address. So, in a nutshell, if we talk about what are the functions of the data link layer, this being an important layer is performing so many functions. One is the framing, that is kind of dividing the data into frames, and also it provides a way for the sender to transmit a set of bits that are meaningful to the receiver, as I have already told you that the transmission should be error free, and for this in order to accomplish this error free transmission, this is going to, or your data link layer is going to attach some special bit patterns to the beginning and to the end of the frame in order to check that whether this frame is kind of intact or is being disturbed while getting transferred onto the physical media. After creation of frames, your data link layer also adds the MAC addresses, or we can say physical addresses of the sender and of the receiver in each of the frame inside the header. So, each and every frame is having header. Physical addressing is being done, that means those MAC addresses of sender and receiver are being, we can say, encoded or being inserted inside this inside the headers of the frame. Error control, I have already told you that data link layer provides the mechanism of error control, in which it will kind of going to detect and retransmit the damaged or lost frames. Apart from error control, flow control is also the responsibility of data link layer. Flow control in the sense that a slow receiver should not be overwhelmed or overswammed by a fast sender. So, a flow control is to be coordinated between the sender and the receiver. So, the data rest must be constant on the both sides, else the data will be kind of corrupted, we can say. Also, last but not the least, access control. So, when a single communication channel is shared by multiple devices, your MAC sublayer, which is the sublayer of this data link layer, it helps to determine which device is going to control the channel for a specific for a specific period of time. So, here in this figure you can see your data link layer is going to perform the function of frame creation, then local error free network delivery is the responsibility of this, and in this way this is going to transfer the frames onto the network. So, in this lecture we have seen what actually OSI model is, what is the importance of this ISO OSI model, and we have looked into the detailed functionality of two layers, which are the physical layer and your we can say the second one, which is the data link layer. Upcoming 5 layers are more to be considered, that I will be taking up in the next lectures. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.